Here, giving f prime of x, graph the antiderivative of x given f of 0 is 100, show all critical point plus inflection point of f and give their coordinates. So here, we're giving the graph of the derivative, and we want to go backward to graph the antiderivative. Here, we want also to find the values of the function at the critical points and the inflection point. So the first step is to observe the behavior of f prime of x when it's positive, negative, and when it's increasing and decreasing. When it's positive and negative, here we have 4 segments. Note here the first region, since f prime of x is below the x-axis, it's gonna be negative. And then on the second region, it's gonna be positive since it's above the x-axis. And then on the third, it's gonna be negative since it's under the x-axis. And then the fourth, it's gonna be positive since it's above the x-axis. Now, when it's increasing or decreasing, here we will have 3 segments based on increasing or decreasing. On the first region, f prime of x is increasing. On the second, it's decreasing. And on the third, it's increasing back again. Now, I'm gonna use this yellow note. So now, after we observe the behavior of f prime of x, we can determine the behavior of x based on this note. Note that the second note, it says a critical point when we have f prime of 0, that is when we have a crossing of the x-axis, and then we're gonna have inflection point of the antiderivative when we have a maximum or minimum of f prime of x. So note here when it's positive or negative, on the first region f prime of x is negative, therefore the function there decreasing. On the second, f prime is positive, that means the function there it's increasing. And then it's negative again, that means antiderivative of x gonna be decreasing. And then f prime is positive, that means f of x antiderivative will be increasing. Notice here the local maximum or minimum. How we consider the critical point to be a local maximum or minimum? Here what I'm gonna do, I'm gonna graph 2 shapes of the function f of x. One it's increasing and then decreasing, and the second is start to decrease and then increase. In the first part here on the top, we can see that in the middle we have a local maximum. And then on the second, we can see we're gonna have a local minimum. So when the function increase and then decrease, we're gonna have a maximum, and then when it's decrease and increase, we have a local minimum. So we're gonna have here a critical point where f prime is equal to 0, that is when we have a crossing of the x-axis, that is at x equal to 0 and 20 and 30. Now we can see there's a local minimum at x equal to 0 since the function decrease and then increase, and then we're gonna have a local maximum at x equal to 20 since the antiderivative of increase and then decrease. Then we're gonna have a local minimum at x equal to 30 since the function decrease and then increase. Here, notice when f prime of x is increasing or decreasing. On the first interval, it's increasing. That means the antiderivative concave up. And then on the second, it's decreasing. That means it concave down. And then on the third, f prime of x is increasing. That means the antiderivative there will be concaving up. Now, between this concavity, we're gonna have inflection point. So the inflection point gonna be at x equal to 10, then x equal to 25. Now, after determining the behavior of f of x, we can graph the antiderivative f of x. Here on the first interval, f of x is decreasing, and then we're gonna have a local minimum at x equal to 0, and then the function concave up. Now on the second interval, f of x will be increasing and we're gonna have an inflection point and still concaving up. Note our inflection point here gonna be at x equal to 10. On the third interval, f of x will concave down and we have a local maximum at 20 and the function is still increasing. And then in the last interval here, we can see that the function decrease and then increase, and then we're gonna have an inflection point at x equal to 25. And then the function concave down and then concave up. Notice our inflection point here, we're gonna have 2 at x equal to 10 and then at x equal to 25. Notice our critical points, we're gonna have 3 critical points at x equal to 0 and then at x equal to 20 and lastly at x equal to 30. So for a critical point, we're gonna have a local minimum at x equal to 0 and 30, and then we're gonna have a maximum at x equal to 20. And then for inflection point, we're gonna have 2 inflection points at x equal to 10 and then x equal to 25. Here, we want to find f of x of these, of the critical point and the inflection point, that is f of 0, f of 30, f of 20, f of 10, and then f of 25. Here, again, this is the critical point and the inflection point, and this is the graph of f of prime of x. I'm going to arrange these values, the critical point and inflection point. This is important in the following step. So, I'm going to start at f of 0, and then f of 10, f of 20, and then f of 25, and then f of 30. I want to find these, so I'm going to start with f of 0. Note here, the graph of f of the value of f of 0 is given, and it's 100. And then at f of 10, what I'm gonna use the FTC, the fundamental theorem of calculus, which says the definite integral from a to b of f of prime of x dx equal to the antiderivative f of b minus f of a. Here, b equal to 10 and then a equal to 0. So the FTC gonna be the definite integral from 0 to 10 of f prime of x dx equal to f of 10 minus f of 0. Note here, f of 10 is what we want and f of 0 is what we found in the previous step. And the definite integral is just the area under the curve which we can find. So we want f of 10, let's arrange for f of 10. It's going to be equal to the definite integral from 0 to 10 plus f of 0. Now let's find the definite integral from 0 to 10. Note our interval, it's going to be from 0 to 10, and we want to find the area and the shaded in black. So note that this area is an area of a triangle. The base is 10 and the height is 20. And notice here the area is above the x-axis, which means the area is going to be positive. So the area of a triangle is going to be half multiplied by the base, which is 10, and then multiply by the height, which is 20. Now I'm going to move to the left. I'm going to plug the definite integral, half, and then multiply by 10, multiply by 20, and then f of 0 is 100. That will result in 200. Therefore, f of 10 is going to be equal to 200. Now, we want to find f of 20, f of 25, and f of 30. Again, to find f of 20, I'm gonna use the last point that I found, that is f of 10. So the fundamental theorem of calculus gonna be from 10 to 20. So it's gonna be the definite integral from 10 to 20 f of prime of x dx equal to f of 20 minus f of 10. We already know the value of 10 and we want to find f of 20. And the definite integral is just the area under the curve of f of prime of x. So I want to solve for f of 20. That is equal to the definite integral going from 10 to 20 and then plus f of 10. The definite integral here going to be from 10 to 20. So it's gonna be in this shaded region. Note, this is a triangle and it's above the x-axis. It's gonna be half multiplied by the base, which is 10, multiplied by the height, which is 20. Then f of 10 is a 20. That will result in 300. Therefore, f of 20 is 300. Now let's find f of 25. So here, I'm gonna use the last point we found. In this case, it's gonna be 20. Since we know that f of 20 is 300. So using the FTC, the definite integral will go from 20 to 25 f of prime of x dx equal to f of 25 minus f of 20. Now let's solve for f of 25. Going to be the definite integral from 20 to 25 and then a plus of 20. To find the integral, it's just the area, in this case above the curve. Here the area going to be under the x-axis, therefore the definite integral going to be negative. The area going to be half multiplied by the base. The base here is 5 and then the height here is 10. So again, going to be negative since it's under the x-axis. Negative half multiplied by 5 multiplied by 10 and then a plus 100, 300. That's going to be 275. Therefore, f of 25 is 275. Now, f of 30. So again, we're gonna use the last point we did. That is f of 25 since we know the value of it. And then we're gonna use the FTC. So the definite integral from 25 to 30 gonna be equal to f of 30 minus f of 25. I'm gonna solve for f of 30. Therefore, it's gonna be equal to the definite integral going from 25 to 30 and then a plus of 25. Here, the only thing we want to find here is just the area under the curve from 25 to 30. And this it's gonna be this shaded region. Note the area is below the x-axis, therefore the definite integral going to be the negative of that area. So that's gonna be minus half multiplied by 5 multiplied by 10 and then plus 275. That's gonna be equal to 250. Therefore, f of 30 is 250. So let's do a recap in here. So in this equation, we are giving the derivative of f prime of x, and we want to ask to find the antiderivative of x. So first, we observe the behavior of f prime of x, where it's positive, negative, and then where it's increasing and decreasing. And then from that, we determine the behavior of the antiderivative, and then we graph it starting from the given f of 0 equal to 100. And then we determine our critical point and inflection point, and then we use the FTC to find the coordinate of these values.